3, 2, go.
Well, we're back again, and notice the integral was y equals 10e power x squared minus 2x, x minus 1 over 2x minus 2. I just followed the rule. It says here a e to the u, f of x, du dx. Now, I can't cancel these, so I'm going to factor out of 2 from this little guy here. So that's going to give me y equals 10 e to the x squared minus 2x, x minus 1, factor out the 2, x minus 1. Notice that cancels, plus c. 10 divided by 2 is 5. And there's your answer. Just simply follow that simple plug-in rule. Identify all your terms from the given equation. This should become no problem at all. Okay? Let me see if I did any more. I think that's the last example that I did. Yes, I think that was it. Okay, I seem to be missing. I think I'm missing a page. Yeah. Oh. 12.33 is gone.
In your 12 notes?
Yeah.
Oh.
Missing a page. Okay. Well, anyway, I am missing a page.
I think I gave them all back to you, but who knows?
Maybe I didn't include them in there.
Okay, well, we'll have to look at the online posted version too.
Okay, so let's do some now we aren't going to do integral of a natural log here. It's never been on an exam. We have to deal with absolute values. And if I have some time at the end, I will teach it. But we've been told some things that we can eliminate because of the online class. So I'm eliminating that for now because I have to get to chapter 13 because that's definitely on the final. And we only have a few days for that. So let's take some practical examples of the indefinite integral. This is going to be section 12.4, practical examples. Okay, we'll take one in the beginning as is cost. And I'm given that the marginal cost, and you'll see this written as MC equals 3x minus 0.5. No, 3x minus plus 50. I'm sorry, is that 50? Yes. Can't read my writing. Marginal cost. So remember, marginal cost is the derivative. So marginal cost is dc dx, in this case, is 3x plus 50. What do we want to find? Fine, okay. 1, the cost function. And let's see if they want anything else here. Nope, that's it. Just find well, I'm going to put here complete. When they ask for a complete cost function, they want the constant too. So let's set this up as an integral. Notice, here we start with the derivative and we work backwards to the integral. That's integration. When we started with the cost function and we worked forward to the integral, that was differentiation. Here we're doing integration. So we're going to multiply both sides by dx. So dc is 3x plus 50 dx. I'm going to distribute the dx. 3x dx plus 50 dx. Now we're going to add an integral sign. So this becomes C equals, now this is the power rule, that's number 2 over there. I'm given AX, and I have to use the power rule on each term. So I'm going to use it on here. A is 3. This is x to the 1 plus 1. It's x to the 1. Plus A is 50. And what happens with the dx? You remember the integral of dx was always x. Remember? The integral of dy is always y. The integral of dp is always p, etc. So this is going to be 50x plus a constant. So c becomes here, or c of x, really I should write it, is 3 over 2, this is 2, x squared plus 50x plus c. Now that's not your answer. Your answer includes, for practical problems to calculate cost, you need c. In order to get c, you need some additional information. So what additional information will they give you here? So let's add it on. We're now going to find c. So I have to find c. Find the constant. C, okay, constant. If you see a hand there, it's just random. It comes from space-time continuum.
I zoomed in. I couldn't see the hand.
Okay. Find the constant c given what? The fixed costs equals $10,000. Now, what are fixed costs? Fixed costs are those that don't vary with x. So those would be in your constant. So fixed costs happen when what? So fixed costs are really costs when x is 0. Now, in order to find that, I'm going to erase this and just have my answer here now. That's all I need. Okay, so in order to find that, I have to put it in here at x equals 0. I know that C0 equals $10,000. And that's going to equal my function here. 3/2 0 squared plus 50 times 0 plus c. Also, we know that c equals $10,000, which makes sense because c is your fixed cost. I could have gone directly to that. So c of x, which is different than c, is going to be 3/2 x squared plus 50x plus 10,000. And this is your complete cost function. So now if they said find, for example, find C of 10. Okay, so you substitute in for x, 3/2 10 squared plus 50 times 10 plus 10,000. This would be 100. 3/2 of 100 plus 500 plus 10,000. And we're going to get, what, 50 times 3. So it's going to be, this is going to be 150, right? 2 goes into 150. 150 plus 500 plus 10,000. So C of 10 would be equal to
10,650.
What? 10,650, right?
Yep, I'm with you.
10,650. And if you didn't have C, you wouldn't know what it was. You couldn't put 650 plus C. That doesn't help you. Okay, so that's basically one example. Let's take another one.
5 minutes.
5 minutes? Okay. I'll erase this here. Of course, we have this. And let's take another example, practical example. And here we go. All right, a little bit harder. Example 2. We're given the marginal. Now, they might give you, they say MR equals 200 minus 4x. MC equals 50 plus 2x. Okay? So what they want to find here is the x value that maximizes profit. Now you might think that you have to find revenue and costs here. Not really, because how do you find profit? What is the theory? Theory is, I might need a better pen. Theory is to take the derivative, the marginal profit, which is dp dx, and let it equal to 0. All right? So how would you find marginal profit given marginal revenue? Well, let's look at this. Marginal revenue, what are we given here? Marginal revenue is this is P. Sorry, my writing's terrible. dr over dx equals 200 minus 4x. And MC, marginal cost, is dc over dx equals 50 plus 2x. All right, now let's see what we can do here. Suppose I wanted to find the marginal profit. Well, marginal profit is going to be equal to the marginal revenue minus the marginal cost. What's the marginal profit? dp dx. Marginal revenue is dr dx minus dc dx. Well, we already have those. So let's say substituting. Okay, I'm going to get dp dx. I can call this 1. This is 2. Substitute 1 and 2. The RDX is 200 minus 4x minus, I always put a bracket here, I remember to distribute, 50 plus 2x. So dp dx is 200 minus 4x minus 50 minus 2x. Okay? So this is going to be 150. Make sure 150 minus 6x. And that is dp dx. Now what do? To find the critical point, I set dp dx equals 0. So this is going to be 150, bringing that equals 6x. Oh boy. As I get lower here, my writing starts to shake. X is 150 over 6. which comes out to be 25, I believe.
Correct.
Certainly is. Now, that is not my answer. It's asking for the X value that maximizes profit. On a number of tests and homework, I still get this as the answer. This is a critical point. You do not know right now whether this maximizes or minimizes the profit. You have to test it. You either have to use the first derivative sign test, or you have to use the second derivative test.
Oh, we're at time. To be continued in the third installment of this lecture.